to write or explain what the slope of a line is. And what the slope of a line is, what they said is the direction of a line. Absolutely. We've got direction of a line. We've got the change in the height of the x values, the rate of the rise over the run. So I'm getting some really good answers here. The slope of a line is the change in the y value over the change in the x value. So it is the ratio, how fast it climbs or how fast it decreases as we read from left to right. So I'm getting some really good answers. So when we talk about the slope of a line, the slope is the change, and when I'm going to use mathematical symbol delta, it is the change in y over the change in x. So the slope of a line is the ratio of how y changes in reference to how the x changes for two ordered pairs. So what about the equation of the line? So go ahead and give yourself a minute or two to find the equation of a line through those 2 points. And if you don't remember how to find the equation of the line, then the first thing you have to do is find the slope. Now I use delta, but another way that you could have wrote the slope is y2 minus y1 over x2 minus x1. So that is using the ordered pairs x1 comma y1 and y2 or x2 comma y2. And the equation of the line, you have multiple ways of writing it, which is y equals mx plus b. You might be familiar with using this form. You might be familiar with using y is equal to m x minus x1 plus y1, or you might be familiar with y minus y1 is equal to m x minus x1. And if you're not familiar with any of these, that's okay, but these are the 3 ways in which I can represent it. Now, these two are pretty much the same thing, just solving for y. And these are called the point slope, where you need a point and a slope. And this is a slope-intercept. So go ahead and take a minute or two to find the equation of the line that goes through those 2 points. And when you're ready, go ahead and post it in the chat. Let me put this back on record. The question is, how do I find the y-intercept from the 2 ordered pairs? Well, it depends on how you learned it. So if you learned it in this first manner, which I'm not going to do, then you would find the b value that way. I actually prefer using the slope-intercept or the point slope, because it allows me to, and the one I actually use is this one right here, it allows me to find the equation without having to do any back substitution. Now, if you learned it the first way with doing slope-intercept, and those of you who are emailing me privately agree on your equation. So the first thing you have to do is find the slope. So we're going to find the slope first, and it is going to be, I'm going to label this x1, y1, x2, y2. So using the equation of the slope, I have the 7 minus 5, because this is my y2 minus y1, over 0 minus 3, because this is my x2 minus x1. And so for my slope, m, I end up being a positive 2 in the numerator and a negative 3 in the denominator. So that's my slope. And I can write this as negative 2/3. And just bring the negative out front. So then what I have to do is I have to find the equation of the line. So I'm going to use that second one, which is y is equal to m. This is negative 2/3. And then x minus, and it doesn't matter which ordered pair that I use. I'm going to use the second ordered pair, because whenever I see a 0 in any of the ordered pairs, that's the ordered pairs that I use when I'm using the slope-intercept point slope form. So then it's x minus 0, and then plus my y1, or in this case I'm going to use y2, is 7. So my equation is negative 2/3 x plus 7. And that's how we find the intercept. Now, if I would have used the other ordered pairs instead of the 0, 7, it would have looked like this. So let me do this in red. So this is using the other ordered pairs, 3, 5. So what I had, y is equal to negative 2/3 x, and my second ordered pair, now I'm going to use x minus 3 and then plus 5. And I'm going to distribute this negative 2/3 on both of those two terms, and so I have y is equal to negative 2/3 x, and then it's going to be minus minus, so it's plus, and then I have 2/3 multiplied by 3 over 1 plus 5, so y is equal to negative 2/3, and then this is just going to give me plus 2 plus 5. So if I would have used the second ordered pairs, or the first ordered pairs instead of the second, I still would have got the same equation of a line, and I still would have got my y-intercept. And the way I would have got my y-intercept is by putting it into the point-slope form. Now, if you learned it by using this and doing back substitution, that's totally fine. I'm not going to show you how to do it here, but it's totally fine to do it that way. My preferred method, however, is this one, because then I don't have to do any kind of weird back substitution. But it's really up to you on how you find the equation of a line. What other kind of questions do you have for me on number 2? What other kind of questions do you have for me on number 2? Yeah, so the question is, the slope and the intercept all come out when we do the slope-intercept form. So if you use the first one, you'll still get the same answer, but it is some weird back substitution. It's a quick and dirty method, so if you have a really good grasp of the slope-intercept, you can absolutely use a slope-intercept instead of the point-slope, and you're still going to get the same answer. Now, I typically do not teach that, because it's one extra step you have to do to go back and get the right answer. So I'm not going to go over how to do it. There are videos out there, or if you learned it that way, you can use the slope-intercept as finding the equation of the line. I typically don't do that unless students have got a really good idea on how to use the slope-intercept. To find the slopes, the other question is, how do we find the slope? Well, to find the slope, we are stuck with just this part. So to find the slope, we always have to use m equals the change in the y's over the change in the x's. The order in which you write it doesn't matter, and what I mean by that is that I could have wrote this as y1 minus y2 over x1 minus x2. So I could have done my x1s and my y1s first, as long as I am consistent. If I have my x1 and my y1 second, notice how they both have to be second, both in the numerator and the denominator. If I want the y1s to be first, then I have to make sure that I have the y1 in the numerator and the denominator to be first in both of them. It has to be consistent. But the way in which you write it, whether you write y1 minus y2, or if you do y2 minus y1, it doesn't matter, as long as that the order in the numerator and denominator is consistent in the way in which you do the subtraction. What other kind of questions do you have for me on number 1 or 2? Okay, so if there's no other questions, go ahead and do 3 and 4. Think about what's changing and what each piece represents. Now, I'm going to explain again what the slope-intercept form is. So I'm going to go over here and I'm just going to kind of erase stuff and explain what each piece of the slope-intercept form is. So in the slope-intercept form of the equation, the m represents the slope, the b represents the y part of the y-intercept. The y-intercept is an ordered pair, so the y-intercept is 0, b. So the slope-intercept, or the slope-intercept form, which is this one right here, the M represents the slope of the line, B represents the Y part of the Y-intercept. So with that information in your mind, think about what is changing on 3 and 4 in each one of those two equations. So what's going to happen, the question is on 3, what happens when the slope changes but the intercept doesn't? And then the other question on 4 is what happens to all of the lines in which they have the same slope but they have different intercepts?
Of it is going to increase or decrease depending on the number that we plug in for x, but it is always going to have the y-intercept at the point 0, 2.
Yes, and so for number 3, all of them are going to have the same intercept, but they're going to have different slopes. Yes, absolutely. Does anyone want to give me an answer for number 4? What's changing on number 4? Yes, so for number 4, the difference between 3 and 4 is that with number 4, they're all going to be running parallel. So they're all going to be having the same slope, they're just going to be running parallel to each other with different intercepts. So if I were to graph number 3 would look like this. Here's the number 2 on the y-intercept, but all of these are going to be going through the same point. So they're all going to be going through that y-intercept. And then on number 4, what's going to be happening is they're all going to have the slope of a -1/2. So they're all going to be like this. They're all going to be running parallel. So the difference between the two is that with number 3, they're all going to be going through the same point, the y-intercept. But number 4, they're all going to have different y-intercepts, but they're all going to have the same slope. All right. Any other questions on 3 or 4? All right, good thought process. So we talk about the slope as the change. So we call it the change in y, or the vertical change, over the change in x, which is the horizontal change. It's the ratio of the change. Now, when we're talking about a line, it is the slope of the line is that, but most of what we are going to be spending is nonlinear. So we're going to spend a little bit of time in this class on linear equations, but for the most part, we are working in nonlinear equations. So what that means for us is that we are going to have these symbols called delta, that just means change, and we are going to have outputs. So if I'm asked to find f of x2 f minus f of x1 over x2 minus x1, this is the same thing. Except for that I know that when I have y1, this is the same thing as putting f of x1 in. And when I see y2, that's the same thing as putting f of x2 in. So I'm going to do B or A here, and then I'm going to give you one in which you won't. Well, you know what? No, I'm going to give you instead of starting with 4, comma B, I want you to start with 5, comma 7. But I'm going to do a different one. I'm going to do G or number or A here, but I'm going to start out with 1, comma 3. So if they're asking me to find the average rate of change and I don't have ordered pairs, then I can find the ordered pairs based on the fact that this is my x1 and this is my x2. So it's asking me to find on this interval from 1 to 3. So when I see it like this and they ask me to find the average rate of change on the function given this on, the keyword here is on, it is an interval of x's. Okay, so it's not an ordered pair, it is an interval of x's. And so the first side, or the first number that you see, the left number, is your first number that you're going to put in, and that represents x sub 1. The second number that you see represents x sub 2. So if they're asking me to find the average rate of change, the first thing I have to do then is I have to find f of x sub 1, because I know this is y sub 1. So I'm going to put my x sub 1 into my original function. Now I'm using g, so let me just change this to g of x. because it's a g, it's the name of the function. So I'm going to do g of 1. I put g of 1 in there, so that's 2 multiplied by 1 squared minus 9. So my g of 1 is 2 minus 9, so in other words, this is 7. So my first ordered pair is 1 comma 7. And then I'm going to have to do the second point. So here's my second point. I have to find g of x sub 2. This is going to give me y sub 2. So I'm going to put in my second x value, which is 3. So g of 3 is equal to 3 squared minus 9. And that should be negative 7. Helps if I pay attention to my negative, so it's negative 7. So this is going to give me 2 multiplied by 9 minus 9. So 18 minus 9, which is 9. So my second ordered pair is going to be 3 comma 9. Now if I'm asked to find the average rate of change, then all I have to do now is just go back to the slope form, where this is x sub 1, y sub 1, x sub 2, y sub 2. So my average rate of change is equal to 9 minus a minus 7 over 3 minus 1. So 9 subtract a negative 7 is going to give me a positive 16 over 2. So my average rate of change between these 2 points is 8. What kind of questions do you have for me before I have you try from 5 to 7? What kind of questions do you have for me? No questions? We're good? Okay, good question. So the question is, where do I get the order of the x's from? So when I have this interval, so I'm going to be given some sort of interval. The first number in the interval is my x1. The second number on my interval is x2, because the assumption is that when we are given an interval, and it is an interval, that we start on the left of our numeric values and we always go right. So when we are given an interval, the expectation is the first number should always be on the left. It should be the smaller number. So this should be the number 1, and then the second number should be the number on the right, should be the larger number. So that's the 3. So if I'm given an interval between 1 and 3, I should always have the smaller number on the left and the larger number on the right. What other kind of questions do you have for me? Yes, so the question is and you guys can always unmute yourself. Please unmute yourself. If you find that it's hard to type, then type quickly. Just unmute yourself and ask the question. So the question is, we do use the first x value and then to find the first y value that's associated with it. And then we use the second x value to find the second y value that's associated to it. And then once we do that, we just have 2 ordered pairs and we just find the slope of the line just like we normally do, which is the y2 minus y1 over x2 minus x1. Do you have any other kind of questions for me? And again, you can totally unmute yourself and ask the question. All right.
So this is what we're learning right here is going to be a big part of the rest, I'm assuming.
So what we're learning right here is foundations of calculus, actually. So the assumption is that this class feeds into calculus at some point. And because, and Benjamin, I see you raised your hand. Are you the one that's talking to me right now? Oh, anyways. if it's not Benjamin, as soon as I get done, you can ask the question. So, when you are, what this is the foundations of calculus. And when we talk about the average rate of change, it helps us lead into when we're talking about when the graph is increasing and decreasing, which is what we're going to be doing also in this first chapter. And it's important to figure out where it's increasing and decreasing, especially for applications. So if I look at my line or look at my graph, here's the graph. So it looks something like this. So we're actually going to graph stuff like this. And we're going to want to know where my graph is increasing, so where my graph is going up the hill in these two places, because that's going to be important, especially for applications. If it represents and if you're going into finance, and this represents the how your profit is going, then you'll want to know when you're increasing in profit. So the importance of finding the average rate of change helps us lead into finding increasing and decreasing. And it also is the foundations of calculus. So this is just a small snapshot of what's going on in all of this class. It's a small snapshot, but it's important, really important in calculus. And then Benjamin, was that you that raised your hand, or did you have a question? Okay, so one of the questions was, what am I going to do with the 4 and the b? Well, I'm going to get there. First, I'm going to do a very concrete example so that you can see that I am choosing ordered pairs. And I'm going to get back to the 4, b in just a moment. So if there's no other questions, then I want you all to find the average rate of change between the points 5, 7. So I'm going to put this on pause. I'm going to give you a moment to do 5, 7, and then I'm going to do something different than 4b, but then I'm going to have you all try to do 4b. Okay, so let's go through this. I'm going to go ahead and erase this because I don't need it as much as I'm going to need the space for 5 to 7. Erase all of this. Okay, so if I'm asked to find the average rate of change between 5 and 7, this represents x sub 1. So I need to find y sub 1. Y sub 1 is going to be f of x sub 1, which is going to be f of 5. So I'm going to put 5 into my equation, and I have 2 multiplied by 5 squared minus 9. And so I have 2 multiplied by 25, because that's 5 squared minus 9. So I have 50 minus 9, which gives me 41. So my first ordered pair is 5, 41. How are we doing so far? Then the second thing I'm going to do is find my y sub 2. So my y sub 2 is going to be f of x sub 2, which is going to be f of 7. I guess I should be using g's. I should have been using g's this entire time. Is equal to 2 multiplied by 7 squared minus 9. So I have 2 multiplied by 49 minus 9. So I have 98 minus 9, which gives me 89. So my second ordered pair is 7, 89. Okay, how are we doing so far? I gotta check my math because I am sketchy in the mornings. I'm sketchy all the time, but in the mornings I'm especially sketchy. Okay, so now that we found our ordered pairs, then we're going to find our slope. And so it is going to be 89 minus 41 over 7 minus 5. So 89 minus 41 gives me 48. And then 7 minus 2 is 5. And so I get 48 over 2, which gives me 24. Is that right? Check my math. Sketchy. Do we get 24? Yes, no, maybe? Okay, cool. So, what kind of questions do you have for me on this so far? Put this on pause and let's take a look going back to A, and they're asking us between 4 and some value B. Now I'm going to erase all the work that we've done so far, and I'm just going to show you graphically what they're asking us for and what they've been asking us for all along. So what this graph looks like, and if you're like, wow, I went through that really fast, that's okay, because we're going to learn how to graph these. But what this graph looks like is it's a quadratic, and it goes through -9, and so has some kind of shape that looks like this. So this is what the graph looks like for A here. And if I wanted to know, because I had the points, I started out with a point 1 and 3, so 1 and 3, and I wanted to know how it changed between 1 and 3. And then I had the next set of points, which was 5 and 7, and I wanted to know how it changed between 5 and 7. There's going to be times with applications in particular in which you want to start where we have the right side or the left side. So we want to know from some point, if this represents the graph of finance, this is showing the profit, and you want to know what the profit was doing after the 4th month, as an example. For those of you who are pre-med and you are trying to look at, say, recovery rates after you've given people a certain drug, how long does it take for them to recover a recovery rate? Then you want to know what happened after the 4th minute or the 4th hour, the 4th week, or the 4th day. And we want to know how it's changing after that 4th being the point that you care about. Now, B is some point in the future. So if we're talking about time at the 4th month, any time after the 4th month, B can be any value after the 4th month. So we just call it B. And what this will do is allow us to say, we're going to have, instead of having a numeric value, we're going to have an equation for the slope. So we're not going to get the number, say, 1/3 or 42 or 16 or whatever. We're going to have some number that's going to have a B value in it. So if I say the 7th month, I can just put 7 in there. Or if I want the 12th month, I can just put 12 in there. So now what we have is I still need to find y sub 1. So I still find y sub 1. Y sub 1 is still f of x sub 1, which I'm going to put the 4 in there. And so I have 2 multiplied by 4 squared minus 9. 2 multiplied by 16 minus 9. 32 minus 9, which gives me 23. So my first ordered pair is 4, 23. Now that's a nice concrete number. We have a nice concrete ordered pair number. When I'm asked to find some value in the future, and anytime beyond 4, then my y sub 2 is not going to be a numeric number in an integer or even a fraction or a decimal. It's going to have a b attached to it. So y sub 2 is f of x sub 2, which is going to be f of b, which is 2 multiplied by b squared minus 9. And so I'm going to get 2b squared minus 9. So my second ordered pair is going to be the it's going to be b comma 2b squared minus 9. So my second ordered pair is not going to be like 5 comma what we had before, which was 41. It's going to be some b value and then 2b squared minus 9. What that means for us in terms of our average rate of change is our average rate of change is not going to be 24 or 12 or 16 or 1/3. What it's going to be, finding the average rate of change, is this represents y sub 2. So it's going to be y sub 2, which is 2b squared minus 9. And then minus my x, or my y sub 1 is 23, so minus 23 over, and then it's going to be my y sub 1, or y sub 2, which is b, and then minus my x sub 1, which is 4. Numerically, in the numerator, I can add the negative 9 and the negative 23, and so I've got 2b squared minus, when I do this subtraction, I'm going to get back to what I started with, which was 32 over b minus 4. And then my numerator factors. So I'm going to factor out a 2, because in my numerator, they both have a 2 that they have in common. So my greatest common factor between those two terms is 2. So I'm going to factor out that 2, leaving me b squared minus 16. And then I have b minus 4 in my denominator. And so in my numerator, I'm going to have 2. The b squared minus 16 is the difference of squares. So this is b minus 4, b plus 4, and then b minus 4 in the denominator. And so the b minus 4's will cancel, leaving me 2b plus 4. And so that is going to tell me what my average rate of change is for any number beyond 4. All I have to do is just put that number in. So if I want to know at 4.5, then I just put 4.5 wherever I see 5, or wherever I see b. So anything that is on the right side of 4, any number on the right side of 4, all I have to do is put that number in for b, and that's going to tell me my average rate of change, and I won't have to do it a number of times. I just do it, and I'm done. What kind of questions do you have for me on that? I did a lot. There's a lot of algebra going on in there. Heavy algebra. What kind of questions do you have for me? Sometimes, yeah, if you need the extra support. So the question is,